Okay, so we're now in chapter 3. So we will be learning human factors as HCI theories. So, so in chapters 1 and 2, we studied two bodies of knowledge for HCI design. So in chapter 1, we learned some principles. So those are the high level and abstract principles. And then in chapter 2, we learn also some specific HCI guidelines. So now in chapter 3, we'll be dealing with human factors as HCI theories. So we have here in this chapter, these are the learning objectives. So first, we have human information processing. So under here, we have task modeling and human problem solving model, and then human reaction and prediction of cognitive performance, and then we have predictive performance assessment. Then also, we have sensation and perception of information. So we have visual, oral, tactile, and haptic, and multimodal interaction. Then we have human body ergonomics. These are the motor capabilities. So we have Fitts law and motor control. So we have also the others. So these are some other human factor for as HCI theories. So we're now with human information processing. So here it's how we process human information. So any effort to design an effective interface for HCI requires two basic elements. So here we have to understand some computer factors, and also we have the human behavior. So we all know that in designing an HCI, before designing an HCI, it involves two factors. We have the computer and your user. So when you design, you have to consider unsa na mga software imong gamiton or hardware, and also you have to know on how this user react or interact on your interface or your computer. So that's why you have to have these two basic elements in order for you to have to have an effective design for your interface using the HCI. So here, as the main underlying theory for HCI, human factors can largely be divided into two. So we have here cognitive science, explains the human's capability and model of conscious processing of high-level information. So it's when say cognitive science, it's the study of our thoughts, atong mga learnings, and how we organize our mental memory, or which gina-study na siya sa mga psychology and other fields. So it also the study of how our minds works, functions and behaves. So that's it. That's the cognitive science. So we have also here ergonomics, which elucidates how raw external stimulation signals are accepted by our five senses. So when say ergonomics, it's the study of people's efficiency, coefficient ba sila sa lang working environment. So in ergonomics are processed up to the pre-attentive level. So and are later acted upon in the outer world through the motor organs. So when I say pre-attentive, our brain filters and process information So ni atong gina process niya atong subconscious mga processing the subconscious accumulation of information from the environment. So later in this chapter, we're going to have some understanding on how this ergonomics affects as a human factors in HCI guide. Yeah, I mean in HCI theories. So we have here ways of human factors knowledge will particularly help us design HCI. So we have here first the task interaction modeling. So it formulates the steps for how humans might interact to solve and carry out a given task or problem and derive the interaction model. So careful HCI designers will not neglect to obtain this model by directing observation sa iyang users. So dili lang siya mo diretso mo design by observing the mga users, but the designer's knowledge in cognitive science will help greatly in developing this model. So before niya dili na siya mo observe diretso, but igamito niya yung mga thoughts or mag-formulate din siya mga steps kung unsaon niya pag-interact in order to solve and carry out a given task and before the arriving sa isa ka interaction model. So muna siya, that's why it's called a modeling your task or interaction. So that is the interaction the task or interaction modeling. Then next is we have the prediction, assessment, and evaluation of interactive. So interactive behavior. So prediction, assessment, and evaluation of interactive behavior. So here, understand and predict how humans might react mentally to various information presentation and input solicitation methods as a basis for interface selection. So after na naka-formulate na siya mga steps kung saan niya solve sa problem, and here i-predict din niya, evaluate interaction models. Evaluate niya ang interaction models and interface implementation, and explain, i-predict niya ang its performance and usability. So mo na siya ang ways human factors knowledge para makatabang sa isa ka HCI designer. Then we have the task modeling and human problem solving model. So we have here a modeling for a task and a problem solving. So cognitive science has investigated the ways in which humans solve problems, and such a model can help HCI designers analyze the task and base the interaction model or interface structure around this innate problem-solving process. So it will help the HCI designer analyze kung sa yung mga tasks based sa interaction model. So it can help yung to solve the problem. So in general, human problem-solving or information efforts consist of these important parts. So these are we have here the three: sensation, the memory, and the decision maker or the executor. So when we say sensation, which senses external information and perception, which interprets and extracts basic meanings of the external information. So, mo na siya imong mga senses, you're using your senses. Katong di-mention ganiya, the 5 senses. And then we have the memory, which stores momentary and short-term information or long-term knowledge. So this this knowledge includes information about about the external world, mga procedures, mga rules, mga relations, and etc. So mo store ni siya og mga short and long-term knowledge. And then we have the decision maker or the executor, which formulates and revises a plan that decides what to do based on the various knowledge in the memory and finally acts it out by commanding the motor system. So basically siya ang execute sa isa ka task. So for example, when you click the mouse, mo decide ka it's either a left mo i-click or the right one. So mo na siya ang decision maker or the executor. So these are the three important parts in problem solving or information efforts in HCI. So we have here the figure, the overall figure A, the overall human problem solving model in process, and we have B, the more detailed view of decision maker and executor. So we have already discussed in ganiha the information processing that consists we have the sensation katong ganiha. So from the information processing, it goes down to sensation. So unsa ni siya mga sensation information? These are those your visual and oral and haptic raw information. So later we'll be discussing that different kinds of sensation information. Then after the sensation, it goes down to the perception, in which it interprets niya mga raw information from the sensation information. Then it goes down to storing of information to your short and long-term memory. Then after storing, mag-design na din siya or execute the information. Then if naka-design na siya, then it will then goes to take the action, proper action. So mo siya ang the overall human problem solving model. So from the right side, we have, from the figure B, we have a more detailed view of decision maker or executor. So here, from once problem is defined, so when your problem is already defined, then it goes down to gathering of knowledge or information. So kung naka-gather na ka din, you will take to consider some possible actions. Then you have to, kung na kay mga actions taken, you have to create the plan na dayon. Then after creating the plan, you have to execute it, then observe the result. So whatever the result is, if it may fail, then you have to repeat the process. Then if it goes right, then problem solved. So this is the model, the task modeling in the human problem solving model. So this is the concept of this figure. So let's proceed with the next. So how human reaction and prediction of cognition performance. So we can also predict how humans will react and perform in response to a particular human interface design. So we can predict how human react on a certain design. So there are two aspects of this. So we have one cognitive and the ergonomic. So what is a goal of execution or evaluation? So it explains how user can be left bewildered when an interactive system does not offer certain actions or does not result in a state as expected by the user. So as you can see here in the figure, it's the goal of execution and evaluation. So it's between the gap between the expected and actual output. So from the goal of evaluation, does the system display the expected result? And pag-execute sa Go, does the system offer actions that I expect to apply? So basically, it's the degree, no? It's a degree of ease with which ang user can perceive or interpret whether or not the action they perform was successful. So, mao na siya ang concept behind sa goal of execution. So we have memory capacity also influences the interactive performance. So the memory capacity also can influence the interactive performance. So we have here some short-term memory and long-term memory. So I think we're quite familiar with this, no? Short-term and long-term memory. So when say short-term memory, known as the working memory that contains memory elements meaningful for the task at hand. Humans are known to remember about 8 chunks of memory lasting only a very short amount of time. While long-term memory, retrieving information is a difficult and relatively time-consuming task. So if an interactive system requires expert-level knowledge, it needs to be displayed so as to at least elicit recognition of it rather than relying on recall from scratch. So basically, when you say short-term memory, limited lang yung limited capacity and can hold items for only short periods of time. While ngayon kag long-term memory, it can store unlimited amounts of information indefinitely. That's why it is very difficult in retrieving information. So the more that short-term memory information is used or repeated, so the more likely it is to become part of the long-term memory. So that's the differences when we say short-term memory and long-term memory. Then we have the GOMS. What is this GOMS? Goals, operators, methods, and selection. So it quantitatively estimates the time taken to complete a given task. Therefore, make an evaluation with regard to the original performance requirements. So basically, mag-estimate lang siya kung unsa ang na-take na time after completing the task, completing the task given, and magkuha na siya evaluate with regard to the original performance requirement. Kung sa ang requirement ato na task, yang evaluate din sa base sa result ato or base sa given given task which na gi-estimate niya pila ang time na take. So the original GOMS model was developed mainly for the desktop computing environment with performance figures for mouse clicks, keyboard input, hand movement, and mental operators. Okay, we're done with the human information processing. So right now, let's proceed with another factor, human factor, the sensation and perception of information. So in the previous section, we explained the value and usage of the knowledge of cognitive and high-level information processing to HCI design. So now we're going to shift our focus to raw information processing. So humans are known to have at least five senses, at least for now. So among them, those that would be relevant to HCI are the modalities of visual, aural, the haptic or the force feedback, and the tactile sensation. So these are the modalities that can be applied for HCI. So let's have the visual first. So visual modality is the most, by far, no, the most important information medium. So over 40% of the human brain is said to be involved with the processing of visual information. So in this section, we review some of the important properties of the human visual system and their implications for interface design. So we have parameters of visual and display, detail and peripheral vision, color, brightness and contrast, pre-attentive features, and high-level diagrammatic semantics. So let's go with parameters of visual and display. So when we say field of view or FOV, so this is the angle subtended by the visible area by the human user in horizontal or vertical direction. So as you can see here in the figure, the shaded area. So the shaded area illustrates the horizontal field of view. So the human FOV is nearly 180 degrees in both the horizontal and vertical directions. Ano siya ang shaded area and the FOV. And when I say viewing distance, this is the perpendicular distance to the surface of the display. It may change. It may change with user movements. So viewing distance kanisla ang dotted line. So then next is the display field of view. So this is the angle subtended by the display area from a particular viewing distance. So the display FOV will be different at the different viewing distance. Kung asa ka nag-view, so ma-change ang imong field of view, ang FOV, no, ang shaded area. So kung dani ka na side, so mag-change ang field of view nimo. Depende na siya sa imong kanang viewing distance. So next is we have pixel. So I think you're familiar with this, no? A display system is typically composed of an array of small rectangular areas called pixels. And we have also familiar one, the display resolution. So this is the number of pixels in the horizontal and vertical directions for a fixed area. Then we have last the visual acuity. This is the resolution perceivable by the human eye from a fixed distance. So this is also synonymous with the power of sight. So amount to siya ang mga visual parameters for visual and display. So let's go with the detail and peripheral vision. So detail and peripheral vision. So the human eye contains two types of cells that react to light intensities in different ways. So we have the cones and the rods. So when you say the cones, these are responsible for your color and detail recognition, are distributed heavily in the center of the retina, which subtends about 5 degrees in human FOV and roughly establishes the area of focus, while the rods are distributed mainly in the periphery of the retina and are responsible for motion detection and less detailed peripheral vision. So, mao ni sila ang detail and peripheral vision. So, we have the cones, though mao ni ang responsible nila sa mga color na to nagkakakita, mga detail recognition, while the rods are for those motion detection ang trabaho sa rods. So, these are the detail and peripheral vision. Let's go with the color, brightness, and contrast. So when say brightness, it's the amount of light energy emitted by the object, or as the perceived by the human. Then we have color. Human responds to different wavelengths of light, namely for those corresponding to red, green, blue, and their mixtures. A color can be specified by the composure of the amounts contributed by the three fundamental colors, and also by the hue, saturation, and brightness values. So, I think kapaluntag say color. And then we have the contrast. Contrast in brightness is measured in terms of the difference or ratio of the amounts of light energies between two or more objects. So, relatively difference, lang relative difference in brightness or color between two visual objects. Makita nimo ang contrast sa dua or more na color. Okay. So in this figure, as you can see, these are color and mga brightness, color na ginamit, pwede na to ma-use in doing some interface or your HCI design. So you can see color specification by hue, and then saturation, and value brightness. Then as you can see here in the right side, it applies on the coding of information in the map. So ginagamit siya for temperature levels. So ma-determine na to dani, for example, if red in this area could be hotter weather, temperature. In here, cold, nana ba? So magamit na to siya as coding for some information. So ano siya, visual na mga parameters. And then we have pre-attentive features and high-level diagrammatic semantics. So pre-attentive features are composite, primitive, and intermediate visual elements that are automatically recognized before entering our consciousness, typically within 10 ms after entering the sensory system. So these features may rely on the relative difference in color, size, shape, orientation, depth, texture, motion, and etc. So these mga pre-attentive features are used for this example lugar, for attention focus. So ma-focus imong attention dito based on different sizes. So based on the left, and this left figure, it focus on different sizes, shape, and orientation, while on the right, application to icon design. So mga icon, so it can be you can label it kung makahimo mo mga design or interface. You can use this as your label, like this one, ang red to be enemy kabanta, and enemy, blue friendly, so mga green unknown. Then so aircraft, naka-triangle, you can may legend naman siya as aircraft. Ang circle, infantry. So ma-use naman siya sa imong mga application. So icons. So more I think if you happen to see some applications, mga games, mga application games, yan sila yung mga mga ginagamit na mga icons and color coding, also ilang ginagamit. So that's the pre-attentive features and high-level diagrammatic semantics. At a more conscious level, humans may universally recognize certain high-level complex geometric shapes and properties as a whole and understand the underlying concept. So we have here some examples of diagrams, shapes, objects, or figures with universal semantics. So if kanina diagram is used for relation, path between objects. Then we have here types, strength of relations. Then we have some inclusion or structure hierarchy. Ano sila ng mga shape, diagram. Then we have the order, causality, flow, process, and dependency. So these are the some samples of diagrams with universal semantics. That's for pre-attentive features and high-level diagrammatic semantics. Ano sila mga high-level diagrammatic semantics. Okay. Now, so next to the visual is the oral modality. So oral modality is perhaps the most prevalent mode for information feedback. So the actual form of sound feedback can be roughly divided in three types. We have the A1 is simple beep-like sounds. Then we have some short symbolic sound bites known as air cons. So example ani the paper crunching sound when a file is inserted into the trash can for deletion. So then we have the relative longer as is sound feedback that is relayed from recordings or synthesis. So as we did for the visual modality, we will first go over some important parameters of human oral capacity and the corresponding oral display parameters. So we have also here the oral display parameters, other characteristics of sound as interaction feedback, and the oral modality as input method. Okay, this is the parameters for oral display. We have intensity. So when we say intensity or the amplitude, it refers to the amount of sound energy and is synonymous with the more familiar term volume. So intensity is often measured in the units of decibels. So where 0 decibels is the lowest and the 130 decibels is the highest level of audible sound. And then we have sound can be viewed as containing or being composed of a number of sinusoidal waves with different frequencies and amplitudes. So the dominant frequency components determine various characteristics of sound such as pitch, example ani low or high key, the timbre, example which instrument, and even directionality, where is the sound coming from. So ano siya ang sound. So when I say phase, parameters sa phase, it refers to the time differences among sound waves that emanate from the same source. So phase differences occur because our left and right ears may have slightly different distances to the sound source. So for example, because kung maminaw ka og sounds, it may have a different because of the distance of your left and right ears. So ang imong pagtungog nandiyo is slightly different because from the sound source. So that's the parameters of oral display, the intensity, sound, and the phase. So we have also other characteristics of sound as interaction feedback. So sound ID effectively omnidirectional. So meaning the sound is most often used to attract and direct a user's attention. However, it can also be a nuisance as a task interrupter by the startle effect. So it means it can be attract attention, user's attention, but it can also a nuisance. Then we have it can make use of contrast. So auditory feedback would require 15 to 30 decibels difference from the ambient noise to be heard effectively. So differentiated components can be used to convey certain information. So you need to have it be required to 15 to 30 decibels to be able to make to hear it effectively. Then we have the continuous sound. It is somewhat more subject to becoming habituated than stimulation with other modalities. So it is difficult to make out the oral content when the sound is jumbled masked with multiple sources. So humans do possess an ability to tune in into a particular part of the sound. However, this requires much concentration and effort. So kung na-jumbled and masked among multiple sources, so they it can stimulate your other modalities. So muna siya ang continuous sound. So these are the other characteristics of sound as interaction feedback. Then we have last is the oral modality as input method. So so far the oral modality has been explained only in the context of passive feedback. So as for using it actively as a means for input to interactive system, two major methods for oral modality as input. We have the keyword recognition and the natural language understanding. So when we say keyword recognition, its isolated word recognition has become very robust lately. So it still requires speakers specific training or a relatively white background. Another related difficulty with voice input is the segmentation problem. So as such, many voice input systems operate in an explicit mode or state. So muna siya ang keyword. Abay, you have to segment maglisod ka by segmentation sa imong voice. Then we have the natural language understanding. Language understanding technology is advancing fast, as demonstrated recently by the Apple Siri and IBM Watson, where high-quality natural language understanding services are offered by the cloud. So if you're familiar with the Siri, if you have some Apple devices, Apple phone or iOS, nana sila application na Siri, in which you can command the Siri application. So like as you can see here in the animation, Siri show me something new. So the Siri would now show something which is new to you, or so na gina-offer ang si Siri dayon. So mao na siya ang oral as input method. You can recognize it through keyword and by natural language. So next is the tactile and haptic. So interfaces with tactile and haptic feedback, while not yet very widespread, are starting to appear in limited forms. So to be precise, the term haptic is defined to be the modality that takes advantage of touch by applying forces, vibrations, or motions to the user, and tactile is for sensing different types of touch. So, kaniya visual. Next is the aural. Now is the tactile and haptic. So we have some parameters of the haptic and tactile. So first, we have tactile display parameters, haptic and haptic display parameters, and the multimodal interaction. So tactile display parameters. So these are the parameters. We have the tactile resolution. So the skin sensitivity to a physical object is different over the human body. So the fingertip is one of the most sensitive areas and is frequently used for HCI purpose. So if you happen to kanang mag-apply like kanang mag-require a fingertip nimo copy. So like sa driver's license, after sa picture na the fingerprint nimo. So that application or that device mubasa siya sa imong fingertip like sa if you're in a working nag-work na ka like kanang mag-biometrics kanang like kanang pareho bitaw sa if you're sa gym sa una kanang na mga employee mag-log in o log out so ibutang na nila lang fingertip sa biometrics so makabasa din ang device so that's the tactile. Then next is vibration frequency. Rapid movement such as vibration mostly sensed by the Pacinian corpuscle, which is known to have a signal response range of 100 to 300 Hz. So we have also the parameters for vibration frequency. Then we have the pressure threshold. So the maximum threshold is difficult to measure because when the force torque gets large, the kinesthetic senses start to operate. And this threshold will greatly depend on the physical condition of the user. So like for katong sa example sa biometrics, kung i-press nimo maayo o kusog, so dili siya basahon, then dili kay mabasa sa kuan sa device. So kung ikadaghan mo daghanon malibog nun pud ang device. So ang what we imo buhaton is you have to slightly put some slight pressure para para mabasa sa device. So mo na siya example sa pressure threshold. So that's for parameters, no, tactile display. And then we have haptic and haptic display parameters. So along with the tactile feedback, haptic feedback adds a more apparent physical dimension to interaction. So force feedback and movement is felt by the cells and nerves in our muscle and joints. So mapil na to sa mga cells and nerves in our muscles and the simplest form of a haptic device is a simple electromagnetic latch that is often used in game controllers. So mga game controllers, it generates a sudden inertial movement and slowly repositions itself for repeated usage. So such a device is not appropriate for fast occurring interaction. So kanisla katong mga game control and mga joystick, mga joystick sa una unsa na karon ng mga game controllers. Then we have here more complicated haptic devices are in the form of a robotic kinematic chain, either fixed on the ground or worn on the body. So such devices offer higher degrees of freedom and finer force control. So as you can see here in the figure, we have some mm, ground robotic. So ato mga kuwan, like mga robots, if you kung nabantay mo ng mga innovation summit, like na naman mga robots karon, so makakuan sa detect na sila kung like kanang cars gali madula-dulaan. Makadetect na din sila kung mabangga na sila, hapit na sila mabangga. So, dinulikay sila mga sample sa mga grounded robotic kinematic. And we also the body worn. So, you can see, gamitan, nag-abit siya o sulong niya ang saka device. So, that's the haptic and haptic display parameters. So we have also some important degrees, important haptic display parameters. So we have degrees of freedom. So it's the number of direction in which force or torque can be displayed. Then force range should be at least greater than 0.5 mn. Operating interaction range, how much movement is allowed through the device, and its stability, how stable the supplied force is felt to be. Then, we have also the multimodal interaction. So, after sa haptic display parameters, we'll go with the multimodal interaction. So, conventional interfaces have been mostly visually oriented. So, however, multimodal interfaces are gaining popularity with the ubiquity of multimedia devices. By employing more than one modality, interfaces can become more effective in a number of ways depending on how they are configured. So, kanidani, it composed of one or more modality. If pwede ba siya ang isa ka device, pwede magamitan nimo either at visual or oral or tactile, or pwede more than one modality. So here are some representative examples. So when say complementary, different modalities can assume different roles and act in a complementary fashion to achieve specific interaction objects. So for example, so an oral feedback can signify the arrival of phone call, while the visual display the caller's name. So sa phone, sa mobile nimo, so nay mo tingog, that's oral feedback. Mag-ring din siya. Then mo display din siya through visual ang caller's name. So that's complementary. So that's a sample sa multimodal interaction. Then next is we have redundant. So different modality input methods or feedback can be used to ensure a reliable achievement of the interaction object. So for example, the ring of a phone call can be simultaneously oral and tactile to strengthen the pickup of probability. So oral, ma-apply ni mo diya ang oral and tactile. Redundant man. Then we have also the alternative. So providing users with alternative ways to interact gives people more choices. So for instance, a phone call can be, pwede siya tubagon mo siya by touch a button, no? I-touch yung button, or by speaking the caller's name. So thereby it can promote convenience and usability sa isa ka user. So that's the alternative type sa multimodal interaction. So that's the modal interaction. It composed of one or more modality in your interfaces. So this is the third human factor. So human body ergonomics or the motor capabilities. So so far we have mostly talked about human cognitive and perceptual capabilities and how display or input system must be configured to match them. So in this section, we briefly look at ergonomics aspects. So to be precise, ergonomics is a discipline focused on making products and interfaces comfortable and efficient. So it encompasses mental and perceptual issues. So um, for HCI, we focus on the human motor capabilities that are used to make input interaction. So we start with the Fitts law and then the human motor control. So what is a Fitts law? So Fitts law is a it's a model of human movement that predicts the time required to rapidly move to a target as a function of the distance to and the size of the target. So the movement task index of difficulty ID can be quantified in terms of the required information amount. So we have from the main equation here, an equation where it's the actual time to complete the movement tasks predicted using a simple linear equation. So where movement time mt is a linear function of ID. So where and B are coefficients is specific to a given task. So mo na siya pagkuha sa movement time, but in a way we're not dili na ta mo dig deeper ani ng mga equation. We will not give an example. Okay. So let's just get the concept here sa Fitts law. It's the movement niya, human movement that predicts the time required to move to our target distance, like ani siya from here to there. Kung ibutang sa recycle bin, so iyang solve kung pila ang movement time from here to the recycle bin. So that's the Fitts law, ang concept sa Fitts law. And let's proceed with the motor control. So the most prevalent form of input is made by the movements of our arms, hands, and fingers for keyboard and mouse input. So in addition to discrete event input methods, so modern user interfaces make heavy use of continuous input methods in the two-dimensional or 2D space and increasingly in the 3D space. So we have also here the control display. Ratio refers to the ratio of the movement in the control device to that in the display. Okay, then if the control display ratio is low, the sensitivity of the control is high, and the travel time across the display will be fast. So if the CD or ratio is high, sensitivity is low, and the fine adjustment time will be relatively fast. So here's the motor control. Iyan lang one is atong movements atong arms, hands, and the fingers for the keyboard and the mouse input. So basically, iyang ikuan ang ratio sa movement sa isa ka device to the display. So for like movement sa mouse, kung unsa iyang ang ratio niya sa pag-display din sa screen. Ano siya, motor control. Example sa motor control, kanang pagkuha niya sa ratio sa movement sa imong cursor, sa movement sa imong pagkuha sa mouse, then to the display sa monitor. So that's the example sa motor control. na parameters. So that's for human body ergonomics, no? Then okay, we're on the last human factors. So we have already have some. We have already learned the first is the human information process, then the sensation and perception, and then the human body ergonomics, and we have also other human factors. So there are many cognitive, perceptual, and ergonomic issues that have been left out. Due to the limited scope of this book, we only identify some of the issues for the reader to investigate further. So here we have some other factors like learning and adaptation, modalities other than the big three, such as gestures, facial expression, brain waves, physiological signals like katong electromyogram, your heart rate, skin conductance, the gaze, etc. And we have also the aesthetics and emotion and the multitasking. So these are some of the other human factors. So wala na siya medyo na-cover dyan sa in this book, but you can investigate it further in your own free time. Okay, so I think we're done with this chapter, no? Just to summarize everything, no? So in this chapter, we have reviewed the essence of human factors, including sensation, perception, information processing, and Fitts law. No, and Fitts law as the foremost underlying theory for the design of interfaces for human-computer interaction. So by the very principle of know thy user, it is clear that the HCI designer must have a basic understanding of these areas so that any interface will suit the user's most basic mental, perceptual, and ergonomic capabilities. So masuit niya dito ma-apply niya. So we can also readily see that many of the HCI principles discussed previously in this book naturally derive from these underlying theories. So I think that's all for this chapter. So thank you for your time and for your cooperation.